this one here. So yesterday you learned about the triangle angle sum theorem. Some of you learned about that. Some of you already knew it, which is that the angles inside of a triangle add up to 180 degrees. Who knew that already? That three angles of a triangle add up to 180. So I'm guessing even if you're not raising your hand right now, I'm sure a lot of you already knew that. So we're just gonna say those equal 180. So if you add up the three angles inside of a triangle, it will always add up to 180 degrees. That's how triangles work. So a lot of the math that you did yesterday, and a lot of the math that is in these notes is just the three angles adding up to 180. The other one that was learned by some people was the exterior angle sum theorem, or the exterior angle theorem. And this one says that if you have an angle on the exterior of a triangle, it is equal to the sum of the remote interior angles. And it just says, this says non-adjacent interior angles. What that means is you can draw any triangle, and if you extend one of the sides of that triangle, like if you just keep drawing it past the point where it meets for the angle inside, you get an angle on the outside. That's known as an exterior angle because it's outside of the triangle. And this angle here is always equal to the two interior angles that are not right next to it. So when it says non-adjacent interior angles, adjacent would be this one here that doesn't have a number. So the two that are across from it on the inside of the triangle, those are the ones that add up to equal this one out here. So the angle measure of angle 1 is equal to the sum of measure of angle 2 plus the measure of angle 3. So if you added those two angles together, you would get the one on the outside. Oh. Hello.
Yes, 1, 2.
It's working.
Sorry for the interruption. We have a car parked on 11th Street, a dark blue Honda Civic, Oregon plate 952 NVL. Your lights are on.
Oh. Okay. So, based off of that information, problem number 1 says we're trying to figure out the measure of angle 1, and we have two of the three angles inside of the triangle. So all you'll need to do is,
I have another copy.
listen up, take away those two measurements from 180, and whatever's left over is the measure of angle 1.
Wait, so 24.
24
Take
plus
away.
37 minus 180.
Negative 119.
Maybe just 119.
119.
Okay, they turned it off. All right. Somebody's telling jokes in the office. Yeah, 119 degrees from the measure of angle 1. It is Halloween, so things are going to be weird, right? So, all right. So, measure of angle 1 here, 119 degrees. Problem number 2.
28.
What up?
You add the two angles inside the triangle.
Yeah, so problem number 2 is like this one here, where we have an angle outside of the triangle. So this one out here is equal to those two added together. What's that? So you see how angle 1 is outside of the triangle? The two that are inside of the triangle across from it, those add together to equal this one out here. So all you have to do on this one is say, so if we're going to write this out, it'd be measure of angle 1 equals 76 plus 52. And that's all you have to do, add 76 and 52. And so measure of angle 1, 128 degrees.
So we're not adding one.
Nope, because we're not talking about all three angles inside the triangle here. So we're not using the triangle angle sum theorem for this one. We're using the exterior angle theorem. So this angle out here is equal to those two across from it inside the triangle. Yeah.
Can it be equal? What if there's three angles inside the triangle?
What up? What do you mean?
Three angles.
Like if it shows you all three of them,
Yeah.
we'll talk about that.
No, like the angle right next to the one.
Yeah.
What if it has that angle 2? Then what is 1 equal?
Still equal to the two that are across from it on the inside.
Oh,
Yeah. So we could figure out the angle that's right next to this one on the inside of the triangle, but we just don't need it. Sometimes it'll be there, sometimes it won't. And we'll see what that looks like, Roth, as we go on. It's not going to change. So, Rob, to answer your question, it will not change the relationship between the angle on the outside and those two adding up to equal that one, even if we do know what this one is.
So like for number 4.
Yeah, we'll get there.
Okay.
Let's do number 3 first, though. So number 3, everybody take a look at number 3. Problem number 3, let's go. I want to be quick with this. Number 3, the angle on the outside, the 104, is equal to those two added together. So this time, it's measure of angle 1 plus 79 equals 104. Because the two on the inside that are across from this angle on the outside add together to equal that number. So what number adds with 79 to equal 104?
25.
25. Good. So if you want to, you can do a little bit of an algebra problem here and subtract 79 from both sides. Minus 79 minus 79. Measure of angle 1 equals 25. So the answer to this one, 25. So 25 degrees for the measure of angle 1. So those are just kind of the basics there. Now, number 4, actually every other problem now is going to include some combination of both triangle angle sum theorem and exterior angle theorem. So I'll have a little bit of a combination of those two things. So, Rob, to answer your question here, first of all, there's multiple ways to figure out the missing angles in this one. Like there's a lot of different ways you could do this. So for example, the 84-degree angle here is on the inside of the triangle on the left, right? But it's on the outside of the triangle on the right. So 84 would actually be an exterior angle for this triangle right here. So 84 degrees, this 84-degree angle is actually equal to those two added together. Angle 2 and the 43-degree angle. We are going to figure out angle 3 in a moment. Or we could figure it out now if we wanted to as well. Actually, any one of these 3 angles we could figure out first. Because we have a lot of different ways to figure out angles. So we could say that 2 plus 43, angle 2 plus 43 degrees is equal to 84. Or the 84-degree angle and angle 3 form a straight line, which means they're a linear pair. So these two angles add up to 180. So all the stuff that we learned previously still applies. So linear pairs add up to 180, or you can figure out angle 1 first, because 66 plus 84 plus the measure of angle 1 equals 180, because those 3 angles make a triangle. So there's a lot of things that we could do potentially to figure out angle 1, 2, or 3. As long as we do the right thing to figure out any one of them, we're good. So somebody tell me an angle and we'll figure out that one first. 1, 2, or 3? 3. Okay. So 84 degrees and angle 3 make a straight line, which means they're a linear pair, which means they add up to 180 degrees. So if you take, what's that? Write what down? That equals 180. You can. Yeah. I'm just going to do 180 minus 84 because I know that if I take away 84 from 180, that'll give me the measure of angle 3, which happens to be 96 degrees. And I'm actually going to fill that in here, 96 degrees right there. And the reason why I'm doing that is because we have to figure out more than one angle. So like with the first 3 problems, we're only figuring out one thing. And so we don't need to fill that into the diagram. But if you're figuring out multiple things, just filling in those numbers as you go, not a bad idea. All right, so somebody give me another. Oh, that was not angle 1. Sorry, that was angle 3. 96. Next one, 1 or 2? 2. Okay, angle 2. So angle 2 adds together with the 96-degree angle and the 43-degree angle to add up to 180 because 3 angles in a triangle add up to 180. So if you take 180 and you subtract 96 and you subtract 43, that gives us 41 degrees. So angle 2 is 41. And then we can do the same thing to figure out angle 1, but use 66 and 84 to take away from 180. So how many degrees is angle 1? 30. Good. Angle 1, 30 degrees. Cool. We did 180 and we took away the 66 and the 84 from it to get 30 there. All right. Let's keep going here. For problem number 5, how many degrees is this angle right here? 90. I'm just going to write that in. That's a right angle. That's 90 degrees. I'm going to suggest that we figure out angle 1 first here. Just because angle 1, we already have 2 of the angles inside the right triangle. So we have the 90-degree angle. We have the 43-degree angle. So angle 1 is going to add up with those 2 to equal 180. So
47.
I believe that's correct. Yeah. So angle 1, 47 degrees. So 47. Angle 2, let's see. Angle 2 is right next to 43. It creates a straight line with the 43-degree angle, which means that those two have to be supplementary. So the two of those will add up to 180.
Do 43 and 3 correspond?
No, they don't. The reason is because that's a great question though. So Rob, real quick, the reason why okay, yes, they do correspond. I shouldn't have said no. Yes, they correspond. No, they're not congruent though. So even though 43 and 3 are corresponding angles, they're not congruent because this line is not parallel to that. So if those two lines are parallel, then yeah, they'd be the same, but those lines aren't parallel. Yes, they correspond. No, they're not congruent. So let's figure out, I mean, we could figure out angle 3 if we wanted to right away, but I think 2 is going to be a little bit easier just because those two angles add up to 180. So what's 180 minus 43? $180 minus 43.
137.
Okay, so that angle 2, 137 degrees for angle 2. So 137 for angle 2. All right, now we've got 137-degree angle here. We have a 12-degree angle here. How many degrees is angle 3? Was it 31? All right. So angle 3, 31 degrees. Was that a how? Okay, because if you look at this angle here, the 12-degree angle, and angle 2, and angle 3, those three angles make up a triangle, which means they have to add up to 180. So if you have 137 and 12, take those away from 180, you're left with 31 for angle 3. All right. Number 6. Here we go. Let's keep going. Number 6. How many degrees is angle 1? Yes. Good. Angle 1, 51 degrees. All right. Angle 1 is 51. How many degrees is angle 2?
61.
Yes, it is. Why do you know that?
Because the two angles are congruent.
Those are congruent because they're vertical. Yeah. 61 and angle 2 are vertical angles. Therefore, they're exactly the same. So we're still using vertical angles. We're still using the linear pairs, all that kind of stuff that we learned. We are still using. So angle 2, 61 degrees.
So 180 minus.
So 180 minus 61 minus 68 gave us the 51. And then because 61 and angle 2 were vertical angles, that means they had to be the same. So 2 is also 61 degrees. Now we can take 180 minus 90 minus 61. Yeah, is that what you're asking? Yeah, for sure. So what do we get? 29. All right. So angle 3, 29 degrees. There we go. All right, let's move it on to problem number 7. Problem number 7. I think, who was up? Was it Ivan up next, or was it Angel? Were you up next for the pass? All right. Somebody was up next for the pass after our, let's see. Okay. Yeah, those are good. Okay. Number 7, we have some information that we are given. It says that segment BC bisects angle AB or ACD. So ACD is this one down here. ACD is the 90-degree angle. The 90-degree angle is being bisected by BC, which means that angle 2 and 3 are congruent, and they're each 45, because if you cut 90 in half, you get 45. So right away, let's just write in angles 2 and 3 as 45 degrees. They have to be congruent because this is being bisected. It's 90. Half of 90 is 45, so 2 and 3 are each 45. And then we can find out 1 and 4 pretty easily because we have 2 of the 3 angles in each of the other 2 triangles. So angle 1 would be 87, yeah? Okay. And angle 4 is 52 degrees, good. All right. Turn the page. Let's go. Let's keep going with these. So on the back of this page here, we're going to answer 8 through 11, but we're going to skip 13 and 15. So 8 through 11, 12, and 14. You can cross off 13. You can cross off 15. All right. Number 8. Ooh, 8's an interesting one. 8's super interesting. Let's get angle 1 first, and then let's do angle 3, and then let's talk about angle 2, because angle 2 is kind of a weird one. So measure of angle 1. What'd you get for angle 1 on number 8? What do we think?
64.
64 degrees. Good. So angle 1 is 64.
1 and 2 equal 90.
They would actually, yeah. Everybody see that? Angles 1 and 2 together would equal 90 degrees. Does that make sense? No? All right, so this angle here is 90, right? If you make a straight line, how many degrees are in a straight line? 180. So this part right here is 90, which means the combination of 1 and 2 also has to be 90. So if 1 is 64 degrees, take that away from 90, and that'll give us angle 2. So we can actually get 2 next. So let's just do that. 90 minus 64. What do you get?
26.
26. Good. So angle 2 is 26 degrees. By the way, angle 2 has nothing to do with angle 3. So we're just going to use this right triangle here to get angle 3. So we've got a 54 degree angle, a 90 degree angle. So how many degrees is angle 3? 36. All right. Nice. Okay. That's what we got for number 8. Now, number 9, Ralph, going back to your question about corresponding angles earlier, this time it actually tells us that we have parallel lines. So L is parallel to M. That will be important here. So I'm going to do an arrow here, up, down on L, and an arrow up here on, so L and M, just showing that they're parallel there. So let's take a look here. Let's solve for angle number 5.
155.
Angle 5? How'd you get that? You said 155?
Yeah. Wait, are 49 and 1?
No,
Oh, no.
no, those are not vertical. Angle number 5. Any thoughts on angle 5? Well, let's start with that one. What do you notice? 131. Yeah, why is that, Nancy? Yeah, so 49 degrees and angle 5 are same side interior angles in between the parallel lines, meaning that those two add up to 180. So if you take 49 away from 180, that gives you angle 5, which is 131. Good. So the stuff that you were tested on last week with the parallel lines and stuff, we're still using that too. Anything can come back at any moment when it comes to geometry. Let's figure out angle 4 next, because angle 4 is right next to angle 5. They make a straight line.
49.
Angle 4 is 49 degrees. And you could have figured that out first, because the 49 degree angle up here and angle 4, those are alternate interior angles, which means they're congruent. So that was an option as well. We didn't necessarily take that option, but it is an option. So 49 degrees for angle 4. All right, so what about angle 2?
58.
58, how'd you figure that out?
Because you know that angle 4 is 49.
Uh-huh.
49 plus 73 minus 90.
Good. We have a triangle in the middle, right? Triangle in the middle is made up of angle 2, this 73 degree angle, and angle 4. We just found out that angle 4 is 49 degrees. So if we add those together, 73 and 49, take away from 180, that gives us angle 2, which is 58 degrees. Nice. Angle 2, 58. Most of these problems don't have a particular order to solve the angles in. Some of them you can figure out, right away. Some of them take a little bit of time. How about angle 1? Angle 1 is 73. Now, there's two ways you could figure that out based on what we have figured out so far. The easiest way, if you recognize it, I say easiest, but if you recognize it, this 73-degree angle here and angle 1 are also alternate interior angles. I'm going to put two lines on those. So those are congruent to each other because they're alternate interior, making it 73 degrees for angle 1. Now, the other way to figure that out is 49, 58, and angle 1 add up to 180. So you could do it that way as well. But either way, that's 73 degrees. The wrong thing. For which class? Let's do this first. Once we're done with the notes, okay. All right. So then there's angle 1 is 73 degrees, and then angle 3. What's angle 3 going to be? 107. Good.
Oh,
Because, well, there's actually two ways we could figure this out. It makes a straight line with the angle next to it, 73, so you take it away from 180, or it's same side interior with angle 1, which means they also add up to 180. So there's a couple ways to figure out angle 3. All right, that's it for number 9. Cool, let's move on. Number 10.
Number 10, are two and three like, not three like exactly?
No,
Oh, like,
no, 2 and 3. So this 90-degree angle up here, well, I shouldn't say no, but I can't say yes. We can't say right away that 2 and 3 are being bisected. That 90-degree angle, there's no information to suggest that it's being cut in half. Maybe it is, maybe it isn't. We might find out that it is, but it doesn't tell us that. So we can't just write in right away that 2 and 3 reach 45. It might end up being that that's the case, but there's no information to tell us that that's true. I would either start by figuring out angle 6 or angle 4, because we have angles immediately next to them where we know what they add up to. So let's go with angle 6 first. 38? Yeah. Because that's a 90-degree angle. The bottom part is 52, so the top part needs to be whatever adds to 90, which would be 38. So angle 6 is 38 degrees. All right. From there, I would say let's figure out angle 4. Because the 86-degree angle and angle 4 are right next to each other and they make a straight line. So that means they add up to 180. So how many degrees is angle number 4? 94. Good. So angle 4 is going to get a little bit messy. Maybe let's see. We'll do that. 94 degrees. Because it's right next to the 86-degree angle. It makes a straight line. So angle 4 is 94 degrees. Let's go with angle 5. Let's check out angle 5 next. Because we have a 38-degree angle here. We have an 86-degree angle here. So 5 would complete that triangle. 56. Okay.
would 2 and 3 be 45?
No, that was Rob's question at the beginning, because it kind of looks like that 90-degree angle is being cut in half, right? However, there's nothing up here that says that it is. So kind of like what we had on the first page where it said on number 7, where it says that BC is bisecting ACD, it told us that it was being cut in half. Number 10 doesn't give us that, so we can't just make that assumption. So we'll have to build around it. Maybe they are, but because it doesn't tell us that, we can't assume that they are. All right, so angle 5 is 56 degrees because it adds up with the other 2 angles of that triangle. So 56. All right, now the next one I would say, let's look at angle 1, because 5 and 1 make up the 90-degree angle. 34, okay. So angle 1 is 34 degrees. Because 56 and 34. The angle 1 right there, 34 degrees. Now we can figure out angle, well, we could do 2 or 3. We could have actually figured out angle 3 at the beginning if we wanted to. So again, there's a lot of different ways to piece these things together. Let's go with angle 2 though. 34, 94, take those away from 180. 52, okay. So angle 2 is 52 degrees. So we just learned that this angle is not, this 90-degree angle is not being cut in half. All right. So angle 2 is 52. And then whatever adds with 90 to equal, whatever adds with 52 to equal 90 would be angle 3. 38. Okay. All right. So that is number 10. So there's a lot of different ways to kind of figure these things out. I want you to try number 11 on your own. Try number 11. Yeah. On this over here. I mean, you can. I'm not going to be too picky about whether or not you put that or not, but yeah, we could just as easily. Actually, you know what? I would recommend doing that. I haven't been, but I would certainly recommend it because we are talking about degrees. So yeah, feel free to do that. Try number 11 on your own. Take a couple minutes on that. Sorry, I am just realizing there's a very faint parallel line markings with the top and the bottom lines. That will actually be useful for figuring out angle number 3. So these top and bottom lines are parallel. Oh, sorry, that's not even angle 3, that's angle 8. Sorry, the printer was having some issues last week in terms of actually printing dark enough.
8 and 38.
8 and 1 are congruent. Yeah, because they're alternate interior. Yeah. All right. So there are the answers for number 11. Check to see what you have so far. Hopefully you have a lot of them. Again, 7 and 8, you can only figure out once you know that the top and the bottom are parallel. I barely saw that on, I'm glad I saw that on there. Otherwise, that would have been a little bit tough to figure out. So those are our answers there. So angle 1 is 62 degrees, angle 2 is 71 degrees, angle 3 is 109, angle 4 is 35, 5 is 109, 6 is 29. You should have been able to get the first 6 angles, 1 through 6, you can get without knowing that the top and the bottom are parallel. 7 and 8, you have to know that they're parallel to figure those out. And 7 is alternate interior with this 47 degree angle up here. 8 and 1 are also alternate interior, so those two sets would be congruent to each other, which makes angle 7 47 degrees and angle 8 62 degrees. Are there any questions about how we figured out any of those before we move on? So 7 and 8, you have to know that the top and bottom are parallel. And so that showed up very, very faintly, and I just noticed that at the end there. So angle 1 and angle 8 are alternate interior, which means they're congruent. So once you figure out 1 is 62, 8 would also be 62 because it's alternate interior. And then 7 and this angle up here, the 47-degree angle, also alternate interior. So those also have to be congruent. All right, let's go to number 12. Here's our first like actual algebra problem of the day. What do we know about these three angles here? They add up to 180. So combine the like terms for all three angles. Combine your like terms for all three angles, set equal to 180. Solve for x. And once you have x, plug it back in for each angle to figure out the measures of each angle. So this angle here plus that one adds up to 180 because it's a triangle. So if we add together our like terms, 9x plus 11x is 20x. 20x plus 5x is 25x. So add up all the numbers with x. 9x, 11x, 5x. So that's 25x. And then if you add negative 21 and 2, that gives you negative 23. And if you add 3 to negative 23, you get negative 20 or minus 20. So 25x minus 20 equals 180. I would prefer to combine, like personally, you're welcome to write all of those out as being added together and then combine like terms, but I prefer just to combine them right here and then write the equation here. So to solve for x, we're going to add 20 to both sides. So it's 20 plus 20. That's going to be 25x equals 200.
Okay, did we put 3?
Where at? Yeah, so we had the negative 21 and the negative 2. That added to equal negative 23. And then if you add 3 to negative 23, that gives you the negative 20. Yeah. So 25x equals 200 divided by 25. And what does x equal? What was it? 8. Yeah, x equals 8. Nice. So over on the right-hand side where it says x equals, just write 8. Don't put a degree symbol next to 8 because that's not an angle measurement. That's just the value of x. And so now to solve for the different angles, just plug x back into each individual angle, and you get the angle measurements. So let's see, angle D would be what? How many degrees? 38. Yeah, 8 times 5 is 40. 40 minus 2 is 38. So angle D is 38 degrees. We have 8 for x, yeah. So just take x and plug it in to here. 5 times 8, x is 8. So 5 times 8 is 40. 40 minus 2 is 38. So you just plug these into your calculator now. 9 times 8 is 72. 72 plus 3 is 75, right? So angle E should be 75 degrees. 8 times 11 is 88. 88 minus 21 would be 67. So angle F should be 67 degrees. Now there's a really easy way to see if you did this correctly. You know what that really easy way is to see if you did this correctly? Add up these three angles, 38, 75, and 67. What should you get? You should get 180. Do you get 180? Yeah, it's a really easy way to check your answer. Because once you have these angles here, if these three don't add up to equal 180, something went wrong. But if they add up to equal 180, chances are you did it exactly the way you needed to. And those ones add up to 180. So we're good. Cross off number 13. We're not going to worry about that one. Also cross off number 15. We're not going to worry about that one. We are going to do 14 though. All right. Number 14. What do we know about the angle on the outside of the triangle and those two on the inside? Exterior angle, okay. And what do we know about these two angles in relation to the one on the exterior? What did the front say? Read the next one, the exterior angle theorem. What does it say? Okay, so that would be this angle here, right there on number 14. What does it say underneath that?
exterior drawing is equal to drawing of the two non-residential.
Yep, so the two angles on the inside of the triangle that are across from the exterior angle add up together to equal that one there. So on number 14, the two angles here on the inside of the triangle that are across from the exterior angle, those two add together to equal that one. So a 180 will not be a part of this equation because those two add up to equal that one. So here's what we're going to do. You ready? Listen up. We're going to set that one on the outside equal to those two added together. The one on the outside equals the sum of those two there. So I'm going to write 18x minus 15 equals, let's see, 13 plus 4 is 17, so that's 17x. And then negative 11 plus 1 would be negative 10, so 17x minus 10. So the one on the outside equals the two on the inside added together. Solving for this one's only going to take 2 steps because if we subtract 17x from both sides, 18x minus 17x is just x. So there's nothing to divide by at the end of this one. That's pretty convenient. So x minus 15 equals negative 10. Add 15 to both sides to get x by itself. What does x equal? 5. X equals 5. Now we have to figure out all 4 angle measurements in this diagram. The fourth one is this one here that's blank. But we'll figure that one out too, because we know about triangles. All right, so angle CAB, that's this one over here. CAB is over here. So we're going to do 13 times 5, because x is 5. 13 times 5 minus 11. 54, good. So CAB, 54 degrees. And I'm actually going to put this one on the diagram as well, because there's a missing angle inside the triangle that we also need to figure out. The next one, ABC, that's the one at the bottom. Because if you start with C and you go to A and then down to B, A is the vertex, so A is the middle letter, which is where the angle is going to be at. So that's this one. Yeah. What is it? Yeah, 21 down here at ABC. So 21 degrees for that one. Angle ACB. So I'm going to write 21 in here real quick. So 21 degrees for that one. Angle ACB is the one that is unlabeled.
105.
Why is it 105?
Because when you put that other angle next to it, and then you factor from 180, you can do it.
Yeah. This is just the third angle inside of the triangle. If the two of those, if we know those two, take those two away from 180, that gives us the one that's left over, 105. So angle CAB, that one right there, is 105. Exactly, yep. So that's how we get the one that isn't labeled. So that'll be 105 degrees there. And then to figure out the last one, angle DCB, just plug in x for 5 for x. And that would be what, 75? For the last one? 75 degrees for angle DCB. Cool. All right, let's see. How much do we have left? There's still a few to go. I'll tell you what. This one here, this page is almost exactly the same as what we just did. So I'm just going to say, let's skip this one and let's go to the back. Let's go straight to the back. All right, starting with problem number 8 on the very back. Here we go. So here's an example of a problem that tells us about a triangle, but does not show us a triangle. So the first thing we should do is make a quick sketch. So here we go. Triangle PQR. We don't know anything about this triangle, so just draw a random triangle. Label one angle P, one angle Q, and the other angle R. We don't know any specifics about this other than we have expressions for each of the 3 angles. So it says angle P is x minus 12. I'm just going to put x minus 12 right there. Measure of angle Q is 5x minus 27. And the measure of angle R is 2x plus 3. So there we go. Find x in the measure of each angle. How do we find x? What did we do on problem number 12?
5, 9.
What's up? 8x, why? Yeah, add all three angles together, set it equal to 180 because those are the three angles of a triangle, so they have to add up to 180. So if we combine our like terms, 5x plus 2x is 7x plus one more is 8x. All right, then we're going to put together negative 27, 3, and negative 12. Negative 36. So 8x minus 36 equals 180. That's our equation to solve for x. So we'll add 36, which will be 216, right? Yep, and then divide by 8. What does x equal? 27. All right. So x equals 27. Now take your value for x, plug it back into each of those angles. I think P is going to be the easiest one to figure out. 27 minus 12. 15. All right, so angle P is 15 degrees. Let's see, R. I'm going to do R next because I know that 27 times 2 is 54, and 54 plus 3 would be 57. So 57 degrees for angle R.
Oh, wait.
And then 108 for angle Q. Nice. Now, once again, there's a really easy way to figure out if you did this right. And that is to add those three angles together. If they add up to 180, then you're probably good to go. And these ones do. So nice job. Cross off number 9. We're not doing number 9. Don't worry about number 9. We're going to do number 10 and 12. So you can cross off 11 as well. 10 and 12 are the last two. And then hopefully we'll have just under 20 minutes of work time today. So a decent amount of time to work. Okay. This one here. In triangle JKL, if the measure of angle L is 13 more than the measure of angle K, and the measure of angle J is 7 more than 6 times the measure of angle K, find the measure of each angle. What? Right? Okay. So first of all, draw a triangle. Doesn't matter what it looks like, just draw a triangle. And we got JKL. So put J at one angle, K at another, and then L at the third. Now, this one is a little bit challenging, yeah? So if you read the rest of this first sentence, angle L is compared to which angle? K. All right. Angle J is compared to which angle? K. All right. So L is compared to K, J is compared to K. Between L and K, where are most of the words? Are they mostly with L or K in terms of the words? L, right? Okay. In terms of J and K, are most of the words with J or K? J. So between the two, K has fewer words written about it, right? And so this goes back to like unit 1. Whichever angle or whichever thing has the fewest words written about it, that's going to be X. So whichever has the fewest written about it, that's going to be X. So we're going to say the measure of angle K equals X. The thing that has the least written about it will be X. Everything else will be compared to that. So it says that the measure of angle L is 13 more than K. Now, more than means it happens after the next thing. So it's going to be plus 13. And it's 13 more than the measure of angle K. If the measure of angle K is X, then that would be X plus 13. 13 more than K. K is X. 13 more than X would be X plus 13. The measure of angle J is 7 more than 6 times the measure of angle K. So 7 more than means something plus 7. And the thing that comes first is 6 times the measure of angle K. Measure of angle K is X, so that would be 6 times X or 6X. So those are the 3 angles that we have, and we have a variable now. And every angle in a triangle, the 3 of them have to add up to what? 180. So combine your like terms, So x plus x is 2x plus 6 more is 8. So that's 8x. And then add the regular numbers. What do you get? 20. Oops, 8x plus not equals 8x plus 20 equals 180. So x is added together, regular numbers added together equals 180. So 8x equals 160, because if you subtract 20 from both sides, you get 160. And then what's 160 divided by 8? 20. So x equals 20. Oh, we don't, that's not even a question over here, but we need that. Which angle is equal to x? K. So that means angle K is how many degrees? 20. All right. Let's see. Angle L is 20 plus 13. 33. So L is 33 degrees. J is 20 times 6 plus 7. 127. I want you to add up 127, 20, and 33, and hopefully that equals 180. It should. If we did it right, then it should add up to 180. And I see people nodding. So yeah, we're good. Okay, last one, number 12. Here we go. Number 12, last one. So we got triangle DEF. Let's just go ahead and draw a triangle. DEF. Same idea here for 12 as we just saw with 10. So it says E is 1 more than 3 times F. Angle D is 3 more than 7 times F. Find the measure of each angle. Which of those 3 will be X? F. Good. The measure of angle F is equal to X. And that's because it has the fewest words written about it. There's a lot of words that talk about E. There's a lot of words that talk about D. There are very few words that talk about angle F. The one that has the fewest words is going to be your variable. So that's X. Measure of angle E. Let's do that one next. Measure of angle E is 1 more than 3 times F. 1 more than means something plus 1. And it's 1 more than 3 times F. F was equal to X. So it's 1 more than 3 times X. So 3X plus 1. The measure of angle D is 3 more than 7 times the measure of angle F. So 3 more than means something plus 3. And it's 3 more than 7 times the value of angle F, which is X. So 7 times X plus 3. Now we're going to do the exact same thing we did on number 10. So I want you to do the rest of this one on your own. Figure out X, figure out the measure of angle DE and F. And then we'll be done with our notes. And hopefully the Chromebooks that were wonky are going to get figured out too. Yeah, just take a pause. Yeah. Oh, he's learning this. I was doing this one. Oh, the study guide? Yeah, just drop it in the basket for me. Thank you.
You're going to today because tomorrow we have playoffs and I still
The review you're talking about?
the test.
Yeah, I'm going to try to get the test done today. That's my goal, is to get that in the grade book.
Yeah, 'cause I don't play for tomorrow. So
Oh, I got you. Yeah, I'll try to get it in the grade book. Is there a test that you're missing?
No, I
Okay.
finished all the tests.
Okay.
And I'm working on some.
Sweet. Okay. All right, let's take a look at some answers here for number 12. What does X equal? 16, good. So on number 12, X is equal to 16. If you combine your like terms, you should get 11X plus 4 equals 180. The 3 angles add up to 180. It tells us, solve for x, x is 16, right? Take away 4 from each side, you get 176 divided by 11, x is 16. Okay, so that means that angle F is 16 degrees because F is x. So F is 16 degrees. E would be 16 times 3, which is 48 plus 1, so that's 49. And then 7 times 16 is 112, and 112 plus 3 is 115. So those are our answers. 115 for angle D, 49 for angle E, 16 degrees for angle F. And if you add those up, it equals 180. So that is it for the notes that I was hoping would have been done yesterday, but they didn't. That's all right. We're good.